This is your test 2 geometry review. You're going to write a rule to describe each transformation. So the first thing that I want to do is highlight what is the actual pre-image. While highlighting what the pre-image is in red, the quadrilateral, W is at -1, -1 here. V is at -1, -3 there. And I also wrote down the points after the transformation. W prime is at 5, -1. V prime is at 5, -3. Now what I'm hoping you can see is that the transformation is a reflection. It's not a rotation because none of the points switched orientation, rotated, turned any kind of way. WV was on the left and now WV is on the right. So what I'm hoping you can see is that this is actually a reflection. Because I know that W and W prime and V prime are the exact same distance from each other, I need to figure out what that line of reflection is. So since W is on the left and W prime is on the right, I know that the line must be a vertical line. Coincidentally, X and X prime are in the exact same location, and so the line of reflection is actually the line that you see here, the vertical line. Doesn't matter what the Y values are. This is the line where X is equal to 2. So this is a reflection where the line is X equals to 2. Pause the video if you need to write that down. Number 3 says the same thing. Write a rule to describe each transformation. So I'm going to pause for a second to write down the pre-image. So what happens on number 3, I've wrote down the pre-image points. I is at a -3,3 and J is at a -2,1. I could have used H if I wanted to, but I just didn't. And then the final image over here, I is at 3,2 and J is at 4,0. So what you should see is that number 1, did the polygon change its rotation? Did the points switch in any kind of way? Yes or no? Did it get bigger or smaller? Yes or no? Is anything flipped? Yes or no? So all of the answers to those are no. What happened is I is at the top, J is at the back, H is at the bottom. On the new figure, I is at the top, J is at the back, H is at the bottom. So what that should tell you is that this is actually a translation. As we know it's a translation, our job now is to figure out what is that translation move. So you can use I and J. The translation should be the exact same. So for J, I know to the, whoops, I don't know what happened to my pen. Sorry about that. Anyway, for J, I know that I'm going to the right. And because I know I'm going to the right, every translation rule must start with every X and every Y. This tells us if we have an X and a Y, then what's going to happen? Since I'm going to the right, I know that it's going to be X plus. If I was going to the left, it would be X minus. So it's X plus 1, 2, 3, 4, 5, 6. Comma, for the Y values, I know I went down just the 1. And since we went down, minus 1. And that's going to be your translation rule for number 3. Now, if you want to double check and see if I move the same distance in the same direction, then you go right ahead. But I can look at I and know that -3 plus 6 would give me 3. And 3 minus 1 would give me 2. So that lets me know I did it right. This is now your time to pause the video to make sure that you have number 3 written down correctly. 5 on your review says find the distance between each pair of points. So what I went ahead and did was put it on graph paper to hopefully make it make a little bit more sense. So to find the distance, what you need to do is figure out what is the length going from -2,6 to 4, -4. And to do so, what I'm going to do is use the distance formula. So I'm going to slide this paper to the right, and I'm going to show you what it looks like written out. You have the distance formula written out, and that's a closed parentheses there if you can't see it. Now I can label my points. X1, Y1, X2, Y2. So when I go to substitute that into the distance equation, X1 will be a -2. y1 will be a negative 6. x2 would be a positive 4, and y2 would be a negative 4. So all I'm going to do is plug that into the equation. Take a second, try it out for yourself. Hit pause. Hopefully your distance equation looks a little bit like what you see here. Of course, yes, I want you to simplify the double negatives. You have two double negative sets. And what I said in class was that looks like a sleeping guy. And when you're sleeping, aren't you happy? Two negatives makes a positive. So I'm going to rewrite the equation with the positives. Pause it if you need to. Negatives change to positives. That's what it ends up being. So now I have 4 plus 2, which I know is 6 squared, plus negative 4 plus 6. That's going to be 2 squared. All of this is still underneath the radical. And yes, I'm still finding the distance between those 2 points. So at this point, we'll use some algebra. We know that the square, 6 squared is going to be 36, and 2 squared is going to be 4. So my last step is to add those two values together and find a sum. So the distance is going to be the square root of 40. And like I said, for this class, the purpose, we don't have calculators just yet to use. So the distance is just going to be the square root of 40. Okay. Take a second, pause it if you need to write that down. I do want you to notice, for my people who like using Pythagorean theorem, if you already did, notice that this point right here would be your starting point if you like using Pythagorean theorem. Why? And let's see, let's get a color that works. So we're going from a negative 2 to a positive 4. And so from a negative 2 to a positive 4 on the x-axis is 6. And then to go from a negative 6 to a negative 4, that's going to be 2. And so, Lord, I don't think you can see that. My bad. So it should be 6 and 2. And so what you can see is that we still end up with the same 2 coordinates for those side lengths, regardless if you use the distance equation up top or if you used Pythagorean theorem. Take a second, pause it if you need to. 7 on your review asks you to find the midpoint between the midpoint of the line segment with the given endpoints. So the points that we are given is negative 9, 5 and negative 5, negative 2. So what you're trying to figure out no longer is what's the length between those two. You're trying to figure out where's the middle between those two. And in class, what I told you was if we're trying to find the midpoint, we're really just looking for the average of the 2 points. So give me a second to write down that equation. Pause it if you need to, if you're drawing this graph, okay? And if you can't remember the midpoint formula, you would add the x's, divide them by 2, add the y's, divide them by 2. Just like I did with the distance formula, I'm going to go ahead and label my points. And it doesn't matter, x1, y1, x2, y2. But this can help you when you go to plug those numbers into the equation. So x1, I'll let it be a negative 9. Y1 is going to be 5. X2 will be a negative 5. Y2 will be a negative 2. So all you're going to do is add the x values together, divide them by 2. Add the y values together, divide them by 2. Take a second, pause the video, plug in those values. Hit pause. What you see is what you came up with on your own. So, see if yours match, and if you need to pause the video, go ahead and pause it. Okay, so I'm going to simplify. A negative 9 plus a negative 5. That's me borrowing $9 and borrowing $5 more. All together, I owe you $14. And since I owe you, it's a negative for Miss Gable. Then over here on this side, that's 5 plus a negative 2. That could be thought of as 5 minus 2. So 5 minus 2 is 3. 3 over 2. Now, like I told you, this would be an acceptable answer. But at this point, what I want you to do is simplify whenever you can. So a negative 14 divided by 2, that's a negative 7. And 3 divided by 2, that's 1.5 or 1.5. However you choose to write it, it's fine by me. So this will be a good answer. Negative 7, comma 1.5. would be a good answer because that's about as simplified as you can get. So that's your answer for number 7. Pause the video if you need to write it down. Is a reflection across the x-axis. So what you have to do for number 9, now you want to flip things. Remember, reflection is just a flip. The x-axis is your horizontal axis. Okay, so what happened, I went ahead and wrote down the points. So if you didn't want to see the points, then pause it, I guess, rewind it so that you can start from scratch. But anyway, that's the location for S, T, and U. So what's going to happen is I'm going to flip those points from the top to the bottom. So from quadrant 1 to quadrant 4 on the graph. So it's no secret. You should already know that since U is on the line, U prime and U is going to share the exact same point. So U and U prime are both there at that location. Remember, a point is just a location in space. So then I guess since I started at U, I'll go to T. T prime is going to go from being 1, 2, 3, 4 above to now being 1, 2, 3, 4 below. So this is going to be my location for T prime. The axis didn't change. It didn't go left or right. So it just changed from 5, 4 to 5, -4. The last point on the triangle is S. S goes from 3, 2. And at this point, I'm really hoping that we can write this in shorthand. Every X and every Y, when we have a reflection across the X-axis, what happens is the X value stays the same. It's not going to go left or right, but the Y value is going to change. Remember, that change means that it can go from positive to negative or negative to positive. So applying that rule, 3 is going to stay the same. 2 is going to change into a -2. And that's it. That's your reflection across the line reflection across the X-axis. Pause the video if you need to write it down. Last problem I'm going to do on this video is going to be number 11. Yes, I'll do 13 and 15, but it's going to be on a different video. And I'll upload that one as soon as I get it done. Now, number 11 says graph the image of the figure using a transformation given. So our transformation is going to be a rotation, which means there's going to be a shift. So right now, don't forget, let me get a pen. Every single turn, if I go from pause, every single turn in a rotation. For example, let's say I start off in quadrant 1. If I start off in quadrant 1 and I change it 90 degrees, I'm going to end up in quadrant 2. Okay. But if I start off at quadrant 1 and I go 180 degrees, that's going to put me in quadrant 3. So I started off at 1, went over to 2 for 90, and quadrant 3 would be a 180 degree rotation. Now, quadrant 4 here, running out of colors, y'all. Quadrant 4 from 90 over to 180 over to quadrant 4 would be 270 degrees. And then going all the way complete full circle from quadrant 1, mapping all the way back to quadrant 1. Hopefully you're thinking 360 degrees. Excuse that marker noise. Ew. Pause. Just to say that this triangle here would end up somewhere over here. So what happens with a 180 degree rotation is the X and the Y values, they don't change places like with some of the others. The X values and the Y values just change signs. So what happens here is that every X and every Y changes in that we change the sign on both of the X and the Y value. So I'm going to write those down over here since I'm kind of out of space. Give me a second. You try it. Pause it and try it. Okay, I know I threw it all on there, but I really wanted to make sure that I didn't run out of time. I can only do 15-minute videos. So the pre-image mapped on, well, not mapped, but rotated onto the, let's see, between the third and the fourth quadrant. And that should be your coordinates of your point. All I did was change all of the X's by sign and change all of the Y's. So we went from -4, -2, 1 to 4, 2, -1, 1, 3, 1, -1, -3, -1. That's all. Good luck on your test. Happy studying.